Okay, so then we do 4 times negative 55, which gives us negative 220. And now we're at 15 minus negative 220 would become 15, of course, plus 220, which is 235. Okay? Any questions on number 1?
Do you have any snacks?
Yes.
You do?
No, shh, be quiet. Yes, it'll be, I'll give it to Miss Sartain as well.
Yeah, I have a question.
Yes.
So technically, 3 also fits in the first one. So why did you use the second one?
3 doesn't fit in the first one.
It's less, oh no. Yeah, it's less than 1.
3?
Oh, no, never mind.
Lil, you were having a moment there. Okay. All right, girl. Just a little moment. Hey, no worries though.
I thought it meant greater than.
It happens to the best of us, okay? All right, here we go. Next question. Okay, there's 2 methods to solve this problem. I'm going to show you both ways. The first way is algebraically, using logarithms. The second way is just simply using Desmos, okay? So let me show you the first way. First way is you are going to isolate the exponential part. So we're going to add 5. 11 to the power of n minus 8 equals 59. Step 2, convert it to a logarithmic equation. Log base 11 of 59 equals n minus 8. Last step, put this into the calculator and then add 8. And that will be your value of n. So we go over to Desmos, we hit functions, we hit miscellaneous, we go to the log with the base, log base 11 of 59 plus 8. Our n value is approximately 9.7. N is approximately 9.7. Okay, Ms. Dahl, I'm never going to remember that. How can I use Desmos instead? Let me show you. Okay, I can show you on Desmos. So if you want to do the Desmos way, Desmos, you're going to go and you're going to plug in y equals 11 to the power of x minus 8 minus 5. Put this in parentheses though. And then in the second y equals, you put the right-hand side in. And you look for the point of intersection. Okay? Go to Desmos. Watch. Y equals 11 to the power of x minus 8 minus 5. And then the other one is y equals 54. And then you zoom out. You look for the intersection. And watch what happens. What's our value?
4.
It's 9.7.
Oh, so it close.
That's your x value, 9.7. So I showed you how to do it algebraically, and I showed you how to do it in Desmos. Either way works. Okay, any questions on number 2? Any questions on question number 2? Okay, let me turn my video off. All right. Okay, number 3. Number 3 asks for the restrictions on the domain. The restrictions on the domain are your excluded values. These are the values. Okay. These are the values that make denominator, spell right, denominator 0. Okay? So you need to factor the denominator. What does the denominator here factor to?
X plus 6, x minus 6.
Thank you, Lil. Wait, what? Oh, yeah. Thank you. Ananya helped you. Don't worry. You're having a little bit of a.
Oh, yeah.
It's okay.
X minus 1, not x
Yeah.
minus 6.
Heavens. That's what you meant. Okay, so the denominator factors to x plus 6, x minus 1. So now using those factors, what values of x make the denominator 0? -6 and +1. So your excluded values are x cannot equal -6, x cannot equal 1. Why? Because they would make the denominator 0. Absolutely. Okay, question 4. We're getting there. Identify the equation of the horizontal asymptote. There are 3 rules for horizontal asymptotes. The first thing is you look at the degree, okay, for your rules. Bigger on bottom, y equals 0. Bigger on top, there is no horizontal asymptote. If they are equal, you divide the coefficients. Okay? Equal, you divide the coefficients. Bobo, Botan, eats DC. So look at your degrees. You have a degree of a 1 at the top, a degree of 2 at the bottom. So what's your horizontal asymptote? Y equals 0. Y equals 0 is the HA because the degree is bigger on bottom. Bobo.
I never memorized these, by the way.
Well, now you can.
Wait, so if it was
If it's on the bottom, the degree is bigger at 0. Top, there's no asymptote.
And if they're equal, you take the numbers in the front, the coefficients.
so say the top was x squared, would it just be 1?
That's correct. Okay, number 5. What is the initial amount, rounded to the nearest cent, that you would need to invest into an account earning 11.2% interest compounded daily to have $8,000 in 5 years? Okay. Compound interest. You're using the formula y equals, not y equals, I did that in first period too. I always want to say y equals. It's blessed a equals. A equals P, parentheses, 1 plus R over N raised to the N times T. Yes, you have to know this formula for Wednesday, May 26th.
So
because
you just expect us to memorize every formula?
Absolutely.
Well, worship.
Did they give us any formulas?
Typically, no, unless it's in the context of the problem, okay? So they may give you formulas within the context of the problem, but I cannot for sure tell you yes or no, so memorize them, okay? Compound interest. A is your final value, P is your initial value, R is your rate, N is the compounded times, T is the time. What's your A here?
We go. Oh no, it's 8,000.
It's just A.
A is 8,000 because you want to end up with 8,000. What's your P? You don't know. That's what you're solving for. 1 plus, what's your rate as a decimal? 0.112. Thank you, Ananya. What's compounded daily? 365. Raised to the power of 365 times 5. So this power, I don't have room. 365 times 5, which is 1,825 when you do the multiplication. So to get P alone, I'm going to divide both sides by 1 plus 0.112 over 365 raised to the 1825 power. Okay? And that will give me the value of P. Okay? It's not bad. It's just simple division. Okay, now let me show you what that looks like in Desmos, and I'm going to show you one additional way using Desmos. So I go to Desmos and I just simply type in 8,000 divided by 1 plus 0.112. Ooh. All over 365 raised to the power of 1,825. I need to initially deposit $4,570.07. That's my P value. P is approximately $4,570.07. Now, how could I have done this without doing all of that and just setting it up into Desmos? Let me show you. I go to Desmos and I put the left-hand side of the equation in. I put the right-hand side of the equation in using X as my variable P. Oops. Raised to the 1,825. I zoom out. Watch what happens when my intersection. What do you get? 4,570.07. So that's just another way if you do not feel comfortable doing this division way. Put the left-hand side in, right-hand side in, find the intersection. Okay? Yeah. Okay, let me check chat real quick. Crud, sorry. Some multiple choice, some short answer on your exam. And some like drag and drops and stuff like that. So there's like, when we go through the tutorial, you'll have all those, basically the same types of questions from your test this semester is what you can expect in the EOC. So some fill in, some drag and drops, some multiple choice, 60 total questions, and Desmos is embedded into every question for your use. So when you click that little calculator up at the top on your test day, that's a Desmos mini calculator. Okay?
Will you be posting today's lesson to Canvas?
Yes, I'm currently actually recording it, and then I'll post the recorded lesson, okay?
Okay.
Okay, number 6 gives you a linear function, f of x equals 6x plus 7. And it wants you to find the value of f inverse of negative 41. So we know that when you have a function and then you have an inverse function, the ordered values flip-flop. So when you see xy on f of x, we'll turn to yx on f inverse of x. So in order to find the value, that n looks so weird. Let me fix that. In order to find the value of f inverse of negative 41, we're going to plug negative 41 in for f of x to find x. And that's it. So negative 41 equals 6x plus 7. Subtract 7. Negative 48 equals 6x. Divide by 6. X equals negative 8. F inverse of negative 41 equals negative 8.
What?
Wait, so why is that? Why are you plugging in negative 41 for f of x when negative 41 is f inverse of x?
Because on f of x, on the f of x function, the ordered pair is -8 comma -41, right? That is a true ordered pair on that linear function. So the question that you're trying to find is, what is the value of f inverse of -41? Well, we know if it's on the inverse function, then the ordered pair should be what? -41 comma -8. So the value of f inverse of -41 is -8. Okay? All right, question 7. Given that f of x and g of x are inverses, and f of 4 is -9, find the value for 5 times f of 4 plus 3 times g of -9. Okay, here's what you know. On f of x, the ordered pair is 4 comma -9. What's the ordered pair on g of x? Thank you, Kaylin. So now utilize that information to find the value. What's f of 4? What's 5 times -9? What's g of -9? What's 3 times 4? What's -45 plus 12? Done. Any questions so far? Question 7. Okay. Question 8. Ooh, this one's a tough one. Here we go. Given the cubic polynomial, find all of the zeros, both real and imaginary. How many zeros should this polynomial have? 3. How do you know? The degree is 3. So the first thing I want you to do whenever you're asked for the zeros is to use your blessed Desmos tool, okay? That's what it's there for. Go to Desmos. X cubed minus 8x squared plus 21x plus, was it 82? Yeah. Okay, hit the home button to recalibrate your data, or your graph, not data. Okay, the graph crosses the x-axis only one time. Where? Where does it cross the x-axis? -2. So we know it has one real zero at x equals -2. That means the remaining 2 zeros are imaginary. I'm going to use synthetic division. I'm going to drop it from a cubic down to a quadratic, and then I'm going to use the quadratic formula. Okay, so let's set up synthetic division. -2 goes on the outside. Does anybody remember what goes across the top at the inside?
1 minus 8 plus 21 plus 8.
Got it. Now it's an algorithm. Drop, multiply, add, multiply, add, multiply, add. Drop, multiply, add, multiply, add, multiply, add. I should have gotten 0 because I used a 0 on the outside. Your remaining quotient is x squared minus 10x plus 41. To find the zeros, I have to then use the quadratic formula. The quadratic formula is opposite b plus or minus the square root of b squared minus 4ac all over 2a. Opposite b plus or minus the square root of b squared minus 4 times a times c all over 2 times 1. Under the radical is 100 minus 164, which is negative 64. 10 plus or minus the square root of negative 64, all divided by 2. What's the square root of negative 64? It's an imaginary 8i. So this would turn to 10 plus or minus 8i all over 2. What is the last thing you need to do? Simplify. Divide everything by 2. Your final zeros are 2 imaginary zeros for a total of 3 zeros at x equals 5 plus or minus 4i. 2 imaginary, 1 real, 3 total. I got my 1 real by looking where the cubic polynomial crossed the x-axis. I got my 2 imaginary by using the quadratic formula and finding the imaginary roots. How did I know the other 2 were imaginary? It only crossed the x-axis once. Any questions? All right, number 9. Determine all of the features of the polynomial. To determine the features, you're going to first stick it into Desmos. Okay, x cubed minus, well, I already forgot it, minus 10x squared plus 12x plus 72. All right, zoom out a little. Or zoom in, I mean. Hello. Okay, so this is a cubic polynomial. It has a degree 3. It has 2 turning points. Its relative maximum is 0.667, 75.85. Its relative minimum is 6, 0. It has a 0 of negative 2 with a multiplicity of 1. It has a 0 of 6 with a multiplicity of 2. So let's kind of write some of that stuff right now. Okay, so it's a degree 3. It has 2 turning points. Its relative or local maximum is at 0.667, 75.9, I think it was. Its relative minimum was at 6, 0. Okay. It has zeros of x equals negative 2 with a multiplicity of 1, meaning it only is 1 root. It has a 0 x equals 6 with a multiplicity of 2. How do I know? Because it bounces on the x-axis. It's a double root. Let's talk about end behavior. As x approaches positive infinity, So does y. Y is going up on the right. As x approaches negative infinity, y is going towards negative infinity. And the last thing that we want to look at are the intervals. Where is it increasing? Where is it decreasing? It's increasing from negative infinity to 0.667. It's decreasing from 0.667 to 6. It's increasing from 6 to infinity. And I think that probably is a good summation of all of the features. We did intervals, we did zeros, we did relative max and min, and we did end behavior. Okay, any questions? All right, last one. What transformations take place in order to map f of x onto g of x? F of x is going onto g of x. Where are we starting? You always want to determine where are we starting. So if you think of f of x as your starting place, where are you starting? Which direction horizontally? Which direction vertically? Where are you starting at? Horizontally, you've moved where? Left 4, and where else? Wait, no. Horizontal, where are you starting? So you're starting from a place of being at left 4, up 3. That's where you're starting. That's where you're not. That's not our answer. But if you're starting left 4 and up 3, and g of x is where you're ending, what shifts do you have to make to go from f of x to g of x?
Right 4 down 7.
Right 4 and down 8. Close. Lily's having a little bit of a moment today, okay? She hasn't eaten lunch. You're going right 4, okay, because you were currently left 4. So to go back to just 2 of x, you got to move right 4. And then if you're up at a positive 3 and you're going all the way down to negative 5, you've got to move down 8. Okay? Any questions there? Good? Okay. I'm going to stop the recording. I will provide it for... Oh, hold on. There might be a question. Hold the phone. Lily. Okay. So for... hold on. Let me stop. Okay.